Okay, in this lecture, I'm going to continue with my discussion of Venn diagrams and propositional logic. In the last lecture, I introduced the simplest elements of propositional logic called the atomic propositions, P, Q, and R. And these are the simplest statements in propositional logic, or they're referred to as WFFs, which is an abbreviation for well-formed formulas. Well-formed formulas. Formulas. So P, Q, and R are the simplest. They're called statement letters, and they can refer to simple statements. Like I think in the last lecture I said let P equal today's today is Monday. Well, I'll say it here. Let's say today is Monday. Today is Monday. Today is Monday. Let's say P can stand for today is Monday. Q can stand for it is raining, right? And R can stand for there is class today. Okay, these are just examples. Okay, but anyway, these are the simplest statements, and from these statements, all the other statements are built up by using certain symbols. And here are the symbols. This is the symbol for not, or it is not the case that. So for example, if P stands for today is Monday, then not P would mean it is not Monday today. Let's say, and here's the ampersand, that's for and. So P ampersand Q, this basically means and. Okay, and I'll go over this in more detail, but that's an approximation. So P ampersand Q would stand for P and Q, which would, if this is what P meant and Q meant, it would stand for today is Monday and it is raining. The other symbol we can use, would be P, V, a small v, Q. That's called the vel, or symbol. Vel in Latin, it means P or Q. So P or Q would mean today is Monday or it is raining. And then we can use the arrow, I guess we can see that. This means if P, then Q. So the arrow is if, then. If, then. Okay, so basically the idea is this. In propositional logic, the simplest statements are P, Q, and R. From those simple statements, or from those atomic, because they're the atoms out of which all the other sentences are going to be made, from these atomic WFFs, or well-formed formulas, all the other statements are made, but they have to be made following the rules. There are rules formation that have to be followed. Any sentence or any formula that you get that does not follow the rules is meaningless. It's nonsense in propositional logic. So I'm going to go over the rules, but first let me go over the logical, what are called logical constants. Okay, these are the logical constants. They're called logical constants. Are here. I'll put them out so we'll have them before us. That's the not sign. This is the tilde. It's called the tilde, tilde. It means not, or it is not the case that. The ampersand is and. The V or the vel is or. So and, or, and the arrow. That's all we'll do right now. There's one more, the double arrow, but I'll stick with the arrow right now. This means if, then. So basically, and then we've also got parentheses. We're going to have to use parentheses, to show groupings. So we've also got the left parenthesis and the right parenthesis. We'll have to use those. So basically, the language of propositional logic, to learn it is actually very simple. I mean, we're going to use P, Q, and R. And then we're going to create from these three letters longer formulas, or WFFs, or longer sentences. And we're going to do so by using these symbols, logical constants, 1, 2, 3, 4, and the two parentheses. And I'll put the other one down. We're also going to use the double arrow. So basically that's it. I mean, I don't have to add anything else. When we get to predicate logic, we're going to have to add a couple more symbols. But so anyway, it's a pretty simple language. You could say, I mean, it's much simpler than learning German or French or Spanish. All you've got are three letters and these 1, 2, 3, 4, 5, 6, 7 symbols. That's it. And from this grammar, you say, we're going to build everything else. We're going to build everything else up. So let me explain. Let me just go over really quickly what the rules are, so we'll know how to form sentences. Okay, so let me see here. Let me look at my book that I wrote. Okay, so rule 1. Well, here are the rules. So rule 1. There's only a few rules. So rule 1. P, Q, and R. So rule 1 is that P, Q, and R are atomic well-formed formulas because they are the simplest and most basic well-formed formulas out of which all the other formulas are created. So are WFFs. Okay, that's rule 1. These are the atomic. These are the simplest elements. Atomic, that's rule 1. Rule 2. Now from these atomic statements, or WFFs, we're going to build other compound statements using rule 2, 3, 4, and 5. Rule 2 says it. Rule 2. If A, I'll call it capital A. Well, let me use I won't call it, no, because P, Q, and R. These are the sentences we're going to be using. P, Q, and R. So I'll use Greek letters. That's what most logic books do. If phi and psi are WFFs. So if we have any formula, call it phi and psi. If phi and psi, and I'll give you an example in a second. If phi and psi are if phi and psi are WFFs, then phi and psi is a WFF. Okay, that might look confusing, but let me explain it. Very simple. Phi, I'll give you an example. If phi and psi basically are meta letters, they don't refer to anything in the language. They're simply a way of talking about the different statements that we can create. So if phi and psi are WFFs, then you can always put an ampersand between the two sentences and then put parentheses around them. So let me give you an example. It's very simple. So if phi and psi are WFFs, okay, well then you can put an ampersand between them and put parentheses around them. Okay, so let's just give an example. So, well, if phi, P and Q, for example, are WFFs, right? From rule 1. P is a WFF, Q is a WFF. So in this case here, the phi we're going to substitute for the phi, we'll substitute P. And for the psi, we'll substitute Q. And since the rule says if phi and psi are WFFs, which they are, P is a WFF, Q is a WFF, you can always put an ampersand between them and put parentheses around them. And then you have a WFF. Okay, so this P and Q is a sentence. It's a WFF. It's a well-formed formula in propositional logic. Because we formed it by following rule 2. Now, P and Q is a WFF, right? R is a WFF from Rule 1. R is a WFF. Rule 2 says if phi and psi are WFFs, you can always put an ampersand between them. Well, this one here, this statement here, P and Q, is a WFF. We know that from Rule 2. We just created it using Rule 2. We created this. Now we know that R is a WFF. Rule 2 says you could put an ampersand between any two WFFs, any two sentences or any two formulas. So now we'll put an R there. And then we also have to put parentheses like that. Okay? Because when you Rule 2, you have two, phi and psi, put an ampersand between them, and then parentheses around them. This here now, this formula here, all of this is a WFF, and we got it by applying Rule 2 to R and this statement here, phi and psi. Now another rule, Rule 3, let me do Rule 3. Yeah, well, Rule 3 says this. If phi and psi are WFFs, are well-formed formulas or sentences, then not phi and not psi are WFFs. So you can always put a negation sign before any formula, any well-formed formula. And then you have also WFF. So now we know, for example, let's go back to phi. We already know that this whole thing is a well-formed formula. This one here, we build it up from these what came before. So we know that this whole expression here is a WFF. Rule 3 says if you have a WFF, so we'll call this whole thing phi. If phi is a WFF, which it is, you can always put a negation sign in front of it. So now that's a WFF. So you can see just by so far I've only used Rule 1, 2, and 3, and you can see already just out of these, beginning with these simple atomic formulas, we've created this long well-formed formula just from 3 rules. And in the next lecture, I'll introduce a couple more rules. But for that, let me erase this, and I've got a couple of minutes, so let me say something else. So, I'll come back and review this, because it's a lot, but you could redo the video and watch it again, and get slower. But let me say something else. So let's say we know that P and Q are well-formed formulas. They're sentences in propositional logic. Instead of saying propositional logic, I'll say they're sentences in PL. I'll call the language I'm talking about. We'll call it PL for propositional logic. We know that this is from Rule 1. We know that from Rule 2, P and Q is a well-formed formula. We know from Rule 3 that that's a well-formed formula, because you can always put a negation sign in front of a well-formed formula or a sentence. Now, let's say I'm going to negate this whole sentence here. Then I keep the parentheses, because if I'm going to negate it, I've got to keep the parentheses. But let's say I have P and Q, and I have P and Q, and I'm all finished. I'm not going to do anything with P and Q. And the Rule 4 says, Rule 4, let me add one more rule. Rule 4, you can always remove external parentheses if it won't cause ambiguity. So in this case here, I can take the parentheses off if I'm not going to do it, and it's P and Q. If I'm going to negate it, then I've got to put it back on. Okay, that's all for now, and I'll continue this in the next lecture.